Hello and welcome. Today I'd like to explain you how to create a multi-stage data processing pipeline using Athena. You can imagine that Athena is a serverless interactive query service which is developed by Amazon Web Services, and it's used for analyzing data which is residing in S3. And Athena provides a nice interactive interface which is suitable for running different queries. However, building data analytic pipeline is a challenge in Athena. So in this post, which I wrote in Medium, you can also read the post, or you can watch this video. I show or demonstrate how to create a multi-stage data processing pipeline using PyAthena. So let me get started. For this tutorial, I'd like to use the VS Code, and here I create folder name Athena YouTube. The first thing which is required is to create a virtual environment, and for doing that I'm going to the terminal. I hope that you have installed Python already, and I'm creating a virtual environment by writing python-m vent, and I'm creating a virtual environment like this. Like for example, I say Athena env. By writing that, then this Athena env appears here. So we also require for this tutorial to install a couple of libraries in this virtual environment. For activating the virtual environment, I can write Athena env scripts activate, and now the virtual environment is actually activated. So I'm going to the folder Athena YouTube, cd Athena YouTube, and here basically there's nothing, it's fine, and I'd like to install a couple of libraries in this virtual environment. The first library which we require is PyAthena. The second library which we require is Boto3, and the third library is YAML, PyYAML. I'm installing all of them. It takes a few seconds to install all of these libraries. Now the installation is completed. So I can imagine when you want to use the Boto3 library, or if you want to connect to the AWS ecosystem, you need to have set up credentials for this purpose. And I trust that you have set up these credentials, and normally these credentials are in a .aws folder on your C drive. You can save them, and you normally save them through a profile. So I hope that you have created this profile previously. Here I'd like to show you how you can basically retrieve these credentials to create a connection to PyAthena. So first of all, let me create a main.py folder, and here I'm importing the Boto3 library. Then I'm writing a function AWS credentials Athena connection, and as an input you can give profile name as the input, and then I create a session, and I'm using boto3.session, and I'm passing the profile name which we have set in our system. So let me say I'd like to get the credentials which are set already. So I write credentials equal to session that get credentials, and next I am getting the current credentials equal to credentials that get frozen credentials. The reason for using the get frozen credential is that sometimes you may have some tokens for your credentials, and then these tokens should be renewed. So you can probably use the credentials directly, but here I'm using the get frozen credentials in case there is the token also involved. And I'm defining access key ID here, which is the current credentials, that access key. And also I'm getting the secret access key, secret access, AWS secret access key equals to the current credentials dot access key. And also here you can also get the token as well. In case you have a token, you can say AWS secret AWS session token equals to the current credentials dot token. And to create a connection to the PyAthena or to Athena, you need to create a connection. For doing that, I'm writing connect. First of all, we need to specify a staging directory to save the staging queries, the result of this to the intermediate queries in S3. And for doing that, I'm specifying the bucket name and also folder path. Next, you need to specify the custom region which you have. I'm just bringing these names as some values in S3. You can change it by the names of your own. So if you are using, for example, US East 1, just put US East 1 here. As an example of the region, I'm just writing here, it could be US East 1, for example. And the folder path, this is the bucket name, any specific folder name you can use. So here, for the connect, we need to also import this connect function from the PyAthena. And I'm importing as connect. And now we can actually pass the credentials here, AWS access key ID equals to the AWS access key ID, which we defined before, and also AWS secret access key equal to the AWS secret access key, which we defined before. Here, I'd like to define a cursor class also, cursor class. I'm passing a cursor class, and I'd like to define a pandas cursor class. Normally, when we read the data from Athena, it's good to import it as pandas because pandas gives a lot of flexibility to work with the data. But again, it's just optional here. So I'm defining the pandas cursor here, and I'm returning actually this connection. So we have it here. So we can use it in other parts of our program. This section up to now, I have defined the connection to Athena. So this is a function which you can customize it based on your staging area, based on your region, and also you can pass your profile of your own, and then you can get the connection to Athena. So let me progress further by building a multi-stage data processing pipeline. You require to define multiple stages. So it's not always possible to have one single query, run it in Athena, and then you see the results. But mostly the scenario, the real scenario is that you have multiple stages. So suppose that these multiple stages of the pipeline are defined in these queries. So stage 1.sql, stage 2.sql, stage 3.sql. These are basically your stages of the pipeline, like stage 1, stage 2, stage 3, and stage 4.sql. And I'm putting, let me put all of them in like in a folder named stages to have them in one place. So I'm just dragging and drop them to this stages folder. And now we have the stages available. So as an example of a stage, so for example, in stage 1, you can create a table in Athena. For example, you have a database name. And then you can create a table. Again, as a result, you can use the Parquet format for storing the result in Athena, actually in S3, and also creating an external location in S3. So suppose that this is your S3 pass. Again, custom bucket name which you have and a custom folder path, so you can customize it. So what I mean is that as a result of your query, you can create a table, and this table, the data could be stored in external location of your choice in the Parquet format. You can specify other formats as well, but here I'm specifying Parquet. So here, as a demonstration purpose, I'm writing a very simple query. Select star from DB name. These are just imaginary table names, and from table X, where column name equal to the condition column. So here, as an example, I have defined a stage 1. Again, stage 2 can have the same query, and stage 3 as well. Like, we define different stages and then store data in S3 and then go and run second stage and so on. I don't want to write for the pipeline the code for each stage, but I'm just, as a demonstration purpose, I'm writing the code for the stage. So now the thing is that we have the stages, and basically it's needed that we run these stages like in consecutively, one after another. So for doing that, we need to basically write a function. So let me write if name equals to main. So if name equal to main, just run the main function. I'm just defining the main function here as it is. So this, I'd like to structure the code like this, and here I'm receiving the connection which I defined here, AWS Athena connection, and I'm passing my profile which is available in a .aws folder in your C drive. So I'm getting the cursor out of this connection, and next is to define the stages, to run which stages we'd like to run for our code. So for example, I'm defining a stages as a result of the list. So for example, stage 1 dot SQL, again stage 2 dot SQL, stage 3 dot SQL, and stage 4 dot SQL. And now I am defining or running these stages or running this code. So for a stage in stages, with open, I'm opening the query, stages from the stages folder, plus stage. I'm reading it as query. I'm writing it like this, and then the query string would look like query.read. So it's actually what we do is for each of these stages or queries, we just read them. And in reality, you'd like to, after reading these queries, you'd like to run these queries. So you can simply say cursor.execute, and you pass the query string. And then after you have run all your query, you close the connection, you close the cursor, and also you close the connection. So this is, it looks like that we have a couple of stages and we run them consecutively. However, you can imagine that this pipeline is not flexible at all. So for example, here condition is fixed, table name is fixed, everything is fixed. But what we need to do is to make it a little bit more flexible. For doing that, we need to add something else, or like we need to define the parameter somewhere else. For doing that, I'm defining a folder named config. And inside the config folder, I'm defining a master config.yaml file. Okay, after creating the master config.yaml file, let me fill it with a couple of stages which we'd like to have for our pipeline. I'm writing stages here, and the first stage should have a stage name, which is stage 1, and then I specify a path here, which is stages stage 1 dot sql, and also we can define a couple of parameters here, like param1 with the value 1, param2 with the value 2. For the sake of simplicity, I'm copy paste the stage here, changing it to stage 2. And again, the parameters are fine. You can keep it like that. Again, stage 3. Be careful about the indentation. And also, I'm defining another stage here, stage 4. So it's very much possible to customize it in case you can have, or you can define as many stages as you want, and you can define as many parameters as you like. The reason for defining these parameters is like to inject these parameters to the queries. So for example, I can take the param 1 and go to the query 1, and for example here I can customize it for the stage. You can use its dollar sign and pass the param 1 here. And also, in case you have another column and you want to filter it based on that, you can also define param 2. So you can fully customize your query. You have the possibility, even you can define the bucket name, change the bucket pass here based on a parameter. If you have if you have created this master config, change the stages, then let's go back to the main function and change it also here. First thing is we again read the connection and build the connection to Athena. Instead of hard coding it here, we can say, or you can open our config file or master config file. For doing that, I need to write config master config.yaml, and then I'm reading this file as config file, and I need to use yaml.safe load config file. We actually need to also import the YAML, and here I haven't imported that. I'm importing YAML, and we should be able to read this master config, which is available here. So again, we need to also modify this part, and right now I'm commenting this out. And here I'd like to write a query, like to run the queries consecutively. So I say for query in config stages, it means that whenever I read this config, and then I'd like to read this all the stages. So it's like a dictionary, you know. And for query in config stages, it we like to first of all read the query paths, so meaning to see where this path is located, and this query path here specifies the path of the first query, so we would like to read it in a loop. And the parameters, we can also say query params, and it would be dictionary of parameters, params, query param, then we can read all the parameters all at once. So I'm opening the first query pass, and then we can specify the read as stage. This is the first query, or like in a loop, I'm reading the queries, and then I can define a query string stage.read, and for each parameter and value which is available in params.items, I can go through them. So we define a query string. We define the query string, and now we'd like to update this query string, meaning that inject the parameters into the query, because as I told you, I have defined parameters here. So we need to inject the values to these parameters of the query. So we can do by the replace function, and I'm using this dollar sign here, like this param, and then we inject like as a string of value here, without the, say, sphere of val, and then we can execute each query. So again, to explain it, what I have done here, I have basically read the master config. Next, for each query in the config.stages. So the master config has a couple of stages, and I'm just reading that. And each query has a path. I'm specifying what is the path to know from where I should read the query. Then I also read the parameters which are defined here in a dictionary, and then I'm reading the query itself, stage.read, query string, and then also I am reading like the parameters related to this query, injecting it to this query. So this here, the query is defined, then I'm updating the query by injecting the values here. Then I have the opportunity to execute the query, close the cursor, and also close the connection. Of course, you have the opportunity to schedule this pipeline however you'd like. You can schedule it using Lambda or any of the tools of your interest. But again, the good thing is that you can have a main function here, like a single entry point to your pipeline, and again, you have the separation of concern. So for example, you have defined the connection to Athena here. You can even define a separate module for this, and again, there is a flow of running the pipeline. Each one by one of these stages could get run, and then if you have a big data set, you can narrow it down by running different stages of the query, building complex queries, and then run them one after another. The good thing is, again, that we have a master config.yaml file. We can define as many as parameters which we would like. And then again, this gives us a lot of flexibility to write custom queries, flexible queries with changing of parameters. And again, the good thing is that we have a single point of entry or a single point to define or adjust the parameters. I hope you have enjoyed watching this video. If you have not yet subscribed to this channel, please do so. Thank you very much for your attention, and see you next time.